Okay, everybody, let's do a recap of the lesson. So what we did is basically we're drawing these triangles because the side-side angle, or famously called the angle side-side, or the donkey triangle, has some problems. So we used a protractor. We drew a 40-degree angle, and we made this side be 6 centimeters. We actually measured it 6. And then we knew that side A has to be opposite of angle A. So we tried to draw it and didn't fit. So we know that there is no triangle that exists. So you have to be careful with the angle side-side. You can't just sometimes draw it down and expect it to work. So no triangle exists at all. We can see it from the drawing. And if you tried the math on it, you'd get an error if you used your law of sines. After we did it, I showed the kids you got an error, and it will not work, okay? Now, example 2. Well, example 2 worked. So we took a protractor, drew the 40-degree angle. We made B be 6 centimeters. I actually made it be 6 centimeters. I drew it in there. And then I knew that side A was 7, so I had to make it fit. So I made it fit. Took my 7 and made it fit, and I drew that in. So this triangle does exist, and we use the law of sines to solve it. So, law of sines, it's sine of B over 6 is equal. Hi, Sophie. I'm filming. What's up? Real quick.
I just have, I'm not going to be in Avid on Wednesday.
Okay.
Because I volunteered for the book first.
Oh, fun. Okay, good. I got it. Yes. Now you're on film for years and years and years.
Oh.
You're recording. You're in. Yeah.
Bye.
Oh, bye. So then I used the law of sines, and I found angle B by doing the opposite, sine of B, and I got 33.6. And then I found angle C because 180 degrees, so I subtract from 180. I got 106. And I was able to find little c by the law of sines again. Side C over the sine of its opposite angle equals 7 over the sine of its opposite angle, and I got C to be 10.45. Okay, so we had to draw them, and we drew them. We got to end up solving it. Then on the back side, this one's kind of weird. So it's already done, but I'll show you what happened. So this is we drew the triangle, and then again, I did a 40-degree angle. And then I drew this side to be 6. And then side A has to be 4, which is angle A, side A. And we went through the law of sines. We solved for angle B, sine of B over 6, sine of 40 over 4. And we got B to be 74 degrees. Angle C, right, there's 180 degrees in every triangle. So we ended up getting from 180 degrees, 65.4. And then to get side C, again, we use the law of sines. C over the sine of 65 equals 4 over the sine of 40, and we end up getting 5.6. But this is a weird one. So there are 2 possible triangles. So you could have redrawn this picture like this. The 4 could have been here, okay? And that's very possible. If you draw a triangle like this, that triangle does exist. Think about it. You got your 40-degree angle, side 6, and this side's 4. So there's 2 possible triangles. So I call it the obtuse triangle. So let's only look at this triangle now, okay? So all of a sudden angle B is no longer there, it's here. So angle B is there. The way to get angle B is this little triangle here, 4 and 4, okay? Those are equal, which means these 2 angles are equal. So if those 2 angles are equal, to find angle B, which is this obtuse angle, I subtracted 74 from 180 degrees. So I got 105 degrees for this. And then I started setting up for angle C, 180 degrees in a triangle, subtract from 180, and I got angle C to be 34 because it's a different angle different angle C. Then side C is no longer all the way across, but side C is only this much of it. So to get side C, I set up my opposite, C over the sine of my 34.6 equals my sine of 40, and I found C. Okay, so that's what I had, and that was the homework. We'll practice this again, so if you have any questions, let me know.